Gay-Lussac's law states that at a constant volume, the pressure of a fixed amount of a gas is directly proportional to its absolute temperature. Okay, so it means that the temperature of a container is increased, the pressure will increase. If the temperature of a container is decreased, the pressure will decrease. Okay, so this happens because when we increase the temperature, okay, the particle will move faster. So this will cause the collision between the molecules. Okay, so as the collision increase, okay, the pressure will increase. Okay, so same goes when we cool down or decrease the temperature. Okay, so the particle will move more slowly, so there will be less collision between the wall of the container, so therefore the pressure will decrease. So mathematically we can express it as P over T equal to K. Okay, so K is the constant, P is the pressure, and T is the temperature. Okay, so we also can write the Gay-Lussac's law as P1 over T1 equal to P2 over T2. Okay, so remember that the temperature must be in Kelvin. Okay, so graphically we can sketch as P versus T. Okay, we will get a linear straight line. Okay, so remember that the Gay-Lussac's law is the relationship between temperature and pressure. Okay, so P1 over T1 equal to P2 over T2. Okay, so when the low temperature, okay, it will give low pressure. Okay, if the temperature is high, it will give a high pressure. So let's see the application of the Gay-Lussac's law in tires. Okay, so in a hot summer, okay, so the inflated tire of a vehicle may burst. Okay, so this happens because as the temperature of the air increase, the pressure of the gas inside the tube will also increase. Okay, so after an unbearable point, okay, so the tire will fracture. Okay, so another example of Gay-Lussac's law is the application in the pressure cooker. Okay, so we know that pressure cooker is a sealed utensil for cooking food under steam pressure. Okay, so when heat is applied, the water inside the cooker vaporizes and the steam is produced. So the trapped steam will cook the food faster. Okay, so that's why it is important, okay, for you to release the steam first, okay, before you open up the pressure cooker. Now let's see the calculation with Gay-Lussac's law. The gas left in a used aerosol can is at a pressure of 100 kilopascal at 27 degrees C. If the can is thrown onto a fire, what will the internal pressure be when its temperature reach 927 degrees C? Okay, so first of all, take out the information given in the question. Okay, so we know that given is the pressure and temperature before, and we have the temperature after. Okay, so the question is asking for the pressure P2. Okay, so first of all, remember that temperature must be in Kelvin. Okay, so you have to convert the degree C into Kelvin. Okay, so to convert degree C into Kelvin, you have to plus it with 273. Okay, so after that we know that the equation for Gay-Lussac's law is P1 over T1 equal to P2 over T2. Okay, so we just plug in the values inside the formula. So cancel out the units, so we will get that the pressure is 400 kilopascal.